Hi everyone, I'm Tom. Welcome back to Tom Talks Blockchain. This channel is mostly about blockchain, but longtime viewers know I've held one view. In the next decade, the main character isn't blockchain, it's AI. So, starting from this episode, I'll occasionally slip in some AI content. Today, how large language models actually work ChatGPT. Claude, what's really going on? Let me be upfront about where I'm coming from. I've written code for over 20 years, and for a long time, I used ChatGPT every single day while understanding absolutely nothing about what was happening under the hood. I knew all the words: token, embedding, transformer, parameters, attention, but honestly, those words never assembled into a complete picture in my head. As a programmer, that bothered me. Give me a database, I know tables and indexes. Give me an API, I know there are requests and responses. Give me a program, I can step through its execution, line by line. But a large language model, I stared at it and kept asking myself one question. Where does the knowledge actually live? When I ask it, what color is an apple? Is it looking up an entry for apple somewhere? Is there a database in its belly? And if the answer to both is no, how do tens of billions of ordinary numbers turn into intelligence? Eventually, I spent real time learning this stuff systematically. I had several aha moments. Today, I'll walk you through those moments with as little math as possible. My earliest misconception was treating ChatGPT as a super search engine. We all know search engines. You type keywords, the system retrieves existing documents and returns things that already exist. A large language model is nothing like that. It's essentially a giant pile of numbers. We call them parameters or weights. Roughly 70 billion learned values sitting in there. And they're all remarkably ordinary looking numbers. 0.13, negative 0.84, 0.0027. Obviously, no single number means Paris is the capital of France. No row for apples. Those tens of billions of numbers work together as one enormous mathematical function. This was my first real shift. The model doesn't store the internet itself. It stores patterns. My favorite analogy, a person who has read 10,000 books. 10 years later, he can recite any page. But those 10,000 books changed the way he speaks, the way he reasons, the way he sees problems. A large model is a bit like that. It's not a zip file of the internet. It's more like a mathematical compression. So the next question, those tens of billions of numbers start out random. How do they become useful? The training principle is simple. Make the model do fill in the blank. Predict the next word. Say, the training data contains the sentence, the capital of France is Paris. The model sees the capital of France is and guesses the next word. If it assigns high probability to London, that's badly wrong. High probability on Paris, good guess. The system computes the error, then uses backpropagation to nudge the weights. To nudge the weights in the direction of be slightly less wrong next time. And note, it's not adjusting one weight, it's adjusting billions of them together, a tiny bit each. Then next, blank. And the next. Repeated trillions of times across massive amounts of text. So pre-training is essentially turning the entire internet into trillions of fill-in-the-blank exercises. Here's the part that genuinely fascinates me. Nobody ever assigned this parameter handles grammar. That parameter handles Java. These parameters manage apples. Engineers designed the learning mechanism. The internal representations grew on their own. Let's dig one level deeper. A neural network can't compute directly on characters or words. It only eats numbers. So step 1 is tokenization. A token isn't necessarily a whole word. It might be a word, part of a word, a punctuation mark, or a chunk of code. The tokenizer slices the text and converts it into a sequence of IDs. So when I ask what color is an apple, what the model actually receives is a string of IDs. The IDs themselves carry no meaning at all. They're just indexes. The genuinely interesting part is the next step, embedding. What embedding does is turn each ID into a high-dimensional vector. Sounds intimidating? A vector is just a long list of numbers, possibly thousands. At first, these numbers are meaningless, but during training, they get adjusted over and over. And the model ends learning a space where things with similar meanings sit together. Two things hit me hard. First, those thousands of dimensions have no clean labels. You can't say dimension 27 means animal and dimension 924 means programming. Meaning is smeared across all the dimensions at once. Second, the embedding is only a factory setting. In I ate an apple and Apple released a new iPhone, they start from the same vector. But after the model processes context, their internal vectors head in different directions. And the machinery doing that, context processing, that's the transformer. The transformer is a neural network, and its most famous mechanism is self-attention. The best analogy is a meeting. Every word in the sentence is a person, and everyone is asking, who should I be listening to right now? Take this sentence. The pump stopped because it overheated. When the model processes it, it has to figure out what it refers to. The attention mechanism gives every word 3 vectors called query, key, and value. Here's my read. Query, what am I looking for? Key, what do I have? Value, what info can I give? It takes its query and matches it against the key of every word. The pump scores high. The info in the pump's value gets blended into its new representation. It's not just it doing this every word. It's doing this simultaneously across layers. By the time the layers finish, the vector at each position isn't just a word. It's a representation soaked in the context of the whole sentence. After that, machinery. The final step is simple. Score candidate words in the vocabulary and pick the next word. The raw scores are called logits. Then, softmax turns them into probabilities. For what color is an apple, the next word might be green 45%, red 30%. Then, by some strategy, one word gets picked and appended to the sentence, and the process runs again. That's autoregressive generation. Why different answers? Why do I get different answers to the same question? Because of random sampling, and temperature controls that. Low temperature, stable. High temperature, more varied. But temperature adds 0 knowledge. So when ChatGPT writes you a 1,000-word answer, there is no drafted first step. It just bounces out one word at a time. Every word instantly becomes context for guessing the next one. Deliberate reasoning. Long-form reasoning emerging from next word prediction, that's the most uncanny part. Predicting the next word sounds low-level. How could it produce coding, math, reasoning? To guess the next word well, the model is forced to learn the structure. If you want to guess the next line of Java, you must learn Java's syntax. If you want to guess a derivation, you must capture mathematical relationships. The training objective is that simple. But doing it well at scale, demands richer representations. Honestly, there's no complete theory that predicts it. Deep learning feels like experimental science. We build it, and now we study why it works. I couldn't resist comparing it. Having learned this, I couldn't resist comparing it with the human brain. The similarities first. A few of them gave me goosebumps. One, the brain has no database rows either. Your memory isn't stored in some neuron, it's spread across roughly 100 trillion synapses. Connection strength is the biological version of a weight. Brains do this every day. The pages are forgotten, the patterns remain. Learning changes, connections, same road as training. 3. A theory says the brain itself is a prediction machine, constantly predicting the next input. If that's right, predict the next word may be very deep, but the differences are fundamental. The brain runs on about 20 watts light bulb territory. Training burns a data center's worth of power. More fundamental, the brain never stops learning. A large model's weights are frozen after launch. Chat with it all, you like it, will not get smarter. Next conversation, it won't remember you. A lot of people think they're training it. In reality, you've only changed this context. Not a single weight has moved. And humans have bodies, senses, emotions. The model has only text. So, does this count as real intelligence? I eventually made my peace. It may not matter. If a system can parse requirements, read code, find the bug, and produce a fix functionally, it holds up. AI didn't get strong because of rules. It got strong because of a flexible framework that learns from experience on its own. Let me close with an engineering perspective. The model itself is not the whole product. The model handles generation, but reliable AI needs more. Needs retrieval, tool calling, and verification. When you see an AI product that can search the web, that's all the software layer around the model. That's good news for old programmers. The model layer is genuinely new, but everything around it is home turf, compressed into one paragraph. Everything around it is home turf. Compress this whole episode into one paragraph. Text is sliced into tokens. Tokens become vectors. The transformer processes them using context. One is picked, appended, loop. Training is nudging billions of weights until this loop gets good. There is no answer key inside. There is only one enormous learned mathematical system. And when you scale, guess the next word to this size, it starts to look an awful lot like intelligence. My feeling, the better I understand the details, the less mysterious each part becomes. And the more impressive the whole thing gets, the next decade belongs to AI. Rather than standing aside, finding it magical or scary, understand how it works, then embrace it fully. That's exactly what I'm doing. That's exactly what I'm doing myself. That's it for this episode. If you got something out of it, like, subscribe, and send this to that friend who uses AI every day but can't explain how it works. Like, subscribe, and send this to that friend who uses AI every day but can't explain how it works. See you next time, and thanks for watching Tom Talks Blockchain. Happy coding!